Right. Hello, everybody, and welcome to this special edition of Neo4j Live, featuring a panel discussion about ISO GQL. I'm your host, ABK, and I'm joined by two prominent figures in the graph world, Philip Rathle, the CTO of Neo4j. Hi, Philip.
Hey, Andreas. Hi, all.
And
Nice to see
Stefan.
you.
And Stefan Plantikow, the editor of the ISO GQL standard. Hello, Stefan.
Hello, everybody.
Really great to have you guys here today. And I know this is now news that came out like about a month ago. Stefan, this is news that has been coming in your mind for quite a while. Could you actually explain for people who are just dialing in or who are kind of new to all this, what exactly is ISO GQL? What are those letters and what does this mean?
Yeah, of course, happy to. So first of all, ISO stands for the International Standards Organization, ISO, sometimes also called ISO. And while ISO is the most mature and most official body used by industries throughout the world to standardize how to do things in the various fields. And ISO regulates everything from the size of grain of rice in shipment to electrical wires, plugs, all kinds of things, right? In particular, though, here for our call, it is the most relevant body for standardizing how people talk to databases, right? And of course, everybody knows ISO SQL, which has been used for 35, 40 years. And what SQL is for tables, right? And of course, we're here on a talk about graphs. And what was missing was the standard for graphs. That has now been 5 years in the making. So now, since April, we have actually an ISO standard for querying graph databases. It's called GQL.
And Stefan, we're losing you just a little bit there, but I think I followed most of that. Philip, were you able to follow along there?
Yeah, Stefan, you've got some audio issues. There's a bit of static and a rumble, and now you've gone somewhat silent. Maybe you can change devices.
When I take a quick look at that and so I'll switch over to you then, Philip, because this is all right, as Stefan has just kind of set this up for us. ISO, okay, it's an international standard body, okay, that does all kinds of things, including apparently query languages from SQL that we all have known for forever, but now GQL. And what's Neo4j got to do with all this?
So we, went into, came into the world based on this vision that there's a different way that is suitable for many cases for dealing with real world data. Sort of, we use the word digital twin a lot these days. That wasn't, hadn't really come into being at the time Neo4j came about, or the property graph model came about. But I like it as a way of describing, you have your real world system and it's rapidly moving and it's interconnected, and you want to reflect it as it is in your database. And the dominant model still today, still for many years to come, if not many decades to come, is the relational model. But there you're taking things and converting them into tables. And if they don't already look tabular, like an order form, which we all learn in Database 101, is a classic example of something that fits really well into a table. And then the more you get into complex dynamic real world systems, and then adding on data about different kinds of systems and different kinds of systems, the more complex it gets. So our idea, way back, was to build technology around this model. The property graph model, that was designed specifically for data, for databases, for your data, and storing and retrieving it, analyzing it. And that, we also felt like this is an opportunity for not just us, the company, or our Neo4j community, but for the world. And so to the degree that there's an opportunity for the world, we want it to be available to everyone. Our first small step with that was with the Cypher query language, which we opened in 2015. Mm-hmm. And then in between 15 and 19, we started learning about ISO, learning about standards, learning about what different options existed for getting together with the decision makers of the world for technology matters and database query language matters, and seeing what we could do collectively as a world to come up with a language that is ratified and has a standards body behind it. So that's that's a bit of the history there.
So you touch on a lot of different aspects here. So let's stick on just the data model itself, I guess, for a second. Like you talk about the property graph model, and that's something that Neo4j had come up with. Okay, the idea of a graph. I think maybe everyone who's in technology understands maybe what a graph is. But then as a data structure, in particular as a database, what exactly is the property graph model?
Yeah, so we certainly didn't invent graphs. Give credit to Leonard Euler for that back in the late 1700s. Shout out to Euler. But yeah, the idea that you have a particular kind of graph, so nodes, relationships, where a node can have a label and it can have properties, and relationships can have a type and a direction and properties. But not just that, not just because there are other graph standards. There have been other graph standards over time that have been designed with, for example, principally data on the World Wide Web, or data that's in motion. And so here the focus was, well, data in a database eventually ends up in motion. And so you've got GraphQL, things like that for APIs and data in motion. But as far as data that is stored in a database, retrieving it, having a query language, that's really the focus with property graphs and really the innovation here.
So then for this particular data model, you mentioned Cypher. Cypher was the query language that Neo4j invented to be the query language for this model that, among with other references, ended up contributing to ISO GQL. Stefan, welcome back. Does that sound right? So it was this data model that we had, the property graph model, the Cypher query language is a way to query that, and that eventually, along with some other ideas, got combined into ISO GQL. Is that right?
Well, that is correct. But of course, there's also it's only fair to say there's of course more than one vendor in the market, right? Which is exactly why you go to standards. Right? We already had other players like Kollegger looking at the space. We had Oracle looking at the space with PGQL. We had a lot of folks in the so-called Linked Data Benchmark Council looking at the space and making various suggestions, in particular around the people on the academic research language called GQL. So there definitely was momentum. People wanted to see a standard graph query language. Everybody was, of course, excited about pattern matching, as pioneered by Cypher and Neo4j. And so all these different inputs, right, eventually came together, and we started the standardization process. The end result of which is ISO GQL.
Right. Okay.
Stefan, you're still having some audio crackle, by the way. Like you were understandable, but yeah, still some crackle.
You could try, Stefan, is maybe just try to drop your video and see if your audio just by itself sounds good. Can we? Yeah.
Am I audible? Does this work better?
Yeah, the audio sounds better.
Okay, then we'll do.
We love seeing you, but your voice is beautiful.
Okay, only a little bit better, to be honest. But let's keep going.
Let's leave it with this. Let's go on. So, Stefan, you talked about a couple different languages that fed into this, and this was as an international standards organization effort. This was not, one organization involved in this. There was a cross-organizational between, you mentioned players like Oracle, who's the classic SQL people, but other people that were involved in the creation of this language. Is that right?
Just a second. I'm trying something. I apologize for people on the call.
Whatever you're trying sounds good. Keep going.
Okay.
Yeah, this is
go
live.
with it. That sounds good.
Okay.
Strange,
okay.
As long as we don't have dead air is the only thing that we don't have.
Okay. Anyhow, so I'll try to answer the question. So Beautiful. First of all, ISO, right, as an organization, is for the creation of industrial standards between nations. So it's organized around country boundaries to begin with, right? If you want to take part in ISO, you have to one way or another become a member of your national standards body, which then delegates you to ISO to take part in the kind of discussions and decisions being made there, right? How this works in detail is a bit different from country to country. But usually in most Western countries, you either pay a fee as an individual or you join as a corporation. Now, turns out for database standards, a tremendous amount of work has historically happened in the United States National Standards Body, but also for GQL, we have followed a similar pattern. So a lot of database vendors are just organized in the US National Body. So many of the pre-discussions among various vendors interested in graph databases happen there, but where they're kind of pre-mediated and discussed in great detail, and then we go to official ISO meetings, and of course there also meet experts from other national standards body like the UK, like Germany, like Korea, who then also contribute on that level. So it is a fairly multifaceted affair, where on the one hand you have the dimension of people from different countries coming together, but of course also individual corporations as well as individual experts contributing to the various standards organizations in which they're members.
Okay. Wow. So I think I followed most of that. It sounds like, and I'm trying to think of like, this is not quite like FIFA, but it is like some like international, like there's national level, not quite competitions, but like organizations that then contribute to like an international conversation around this. And it's at the international level where it actually finally becomes an ISO level standard. Like there's like a nation level participation that happens first. Did I get that right?
Yes, thanks. That's a fairly great summary of the situation. Yeah.
Okay. And so let me ask you actually, Philip, about this. So, okay, we kind of understand like this kind of how the standards body worked around this. We've got some of the history about like, the property graph model that, okay, it's not just a graph, but it's a very particular data model for storing, information in a database. And this question has to be asked, and I think this actually came up in when the LinkedIn post went out around this meeting, that relational databases that we've had for a while now have been able to kind of absorb all of their data models, because relational algebra lets you talk about anything, right? Why can't you just do graphs in a relational model? Like, why do you need a new language for that?
So I'm interested in Stefan's answer. He will probably add, but I think the principal reason is that you have the possibility with a graph model of having a schema flexible implementation, and ultimately vendors can choose whether to have a schema flexible implementation or not. But ones that do can't be accommodated by SQL, because SQL requires that you create containers ahead of time that describe the thing that you're going to be storing, and each and every type of that particular thing fits into that same bucket. Whereas with a property graph, you can imagine a world. Actually, this describes today's world, where at one end of the spectrum, you can have complete schema flexibility, and the data that's showing up in the real world, you sort of drop it into your graph as it shows up, completely unconstrained. You could also see a world where you have the opposite, where you're defining everything and statically. And then also you can see a world where you can choose what level of lockdown you want in your schema. And Neo4j's own implementation has started with complete flexibility, and then constraints have been added over time, so that as you understand parts of your data, you can lock that down and have the benefit of applications not needing to rewrite data validation rules themselves, and being able to do that in the database. So that journey's continuing. So that's the principal reason as I see it.
So you described sort of a like a lazy schema. It's save data first, figure out the schema as you go along, and then kind of lock it down over time. Is that the idea?
I look at it as schema being an emergent property of the data versus schema being something that's imposed upon the data, and then having this sliding scale in between.
Right. Okay. Stefan, do you want to give a shot at some commentary on that? Or?
Yeah, how audible am I?
Yeah, you're still a little bit crackly.
I don't know what I can do about that.
Let's try
well, I will try to comment a bit. Stop me if it's non-audible.
I think actually it might be a little too crackly at the moment. If I can dare to recommend this, have you done a hard reboot of Chrome or whatever you're using for a browser?
I'll have a separate computer that I could try. I mean, that's an option, but it will take me 3 to 4 minutes to be back here. Sorry about that. But
I would try other headphones, another audio input device. Sounds like an issue with the audio input device.
It's my regular audio input, but okay. Sure.
Maybe give that a try a little bit. Let us know when you've got something to experiment with it. We'll go on. So Philip, I want to keep going into this aspect of like how this how a graph model and GQL differs from SQL. Something you mentioned earlier that I want to ask a little bit more about is like you talked about like pattern matching, or I don't remember if it was you or Stefan. How does pattern matching factor into this? Because that seems like something that's not natural to express in SQL.
So pattern matching is, and for I think probably those who have joined the call are familiar with this, but just in case not, the way pattern matching works in GQL is actually the way pattern matching works in SQL, where you have your things, which are nodes, which are enclosed in parentheses. You can imagine like that tracing the line and making the circle. And then you have hyphen, hyphen, greater than or less than to show an arrow in one direction or the other. Or in a pattern match, you could just have hyphen, hyphen for a match with either direction. And then, additional annotations for looking at types and so on. So that pattern matching syntax that's in Cypher ends up being the same pattern matching that's in GQL. I remember years ago, someone from Microsoft who came across Cypher for the first time, or particularly it was this pattern matching inside of Cypher that said, this is the most elegant way anyone's ever invented to express joins, which I thought was an interesting way to look at it. It's effectively that.
Right. Okay. And so this notation, which is an elegant way to express joins, it's also then this, like where each, I guess you were saying the parentheses, like, these are the nodes, and then the arrows. It's like the kind of, what is it, the ASCII art I've seen posted about before. People talk about it, like it's as if you're trying to just describe visually the graph in text form as best as you can, but then that becomes the query language.
It is ASCII art as a query language for sure. Yeah. And then everything else around it, we try, the ISO tried and we supported trying to get as much similarity with SQL as possible. And because, there's no point in varying things that people are familiar with and that work if there's no need for it. So as much as possible, the effort was keep things like as they are with SQL as much as possible, but then vary when necessary. And that ended up working. That ended up being very similar to the philosophy we used with Cypher. So early on, the person who invented Cypher, Andreas Taylor, had been a SQL Server DBA, knew SQL in and out, and had this idea of, well, instead of imperatively traversing the graph, which is what you used to have to do, let's describe a pattern and have the database figure out how to access that pattern, enter the world of rule-based planners and cost-based planners and statistics and runtimes and parallel runtime, all this stuff. But his idea was no idle variation from SQL, and that I think has served the community well, and actually incidentally makes Cypher a good on-ramp to those to GQL. Our plan, in fact, is to evolve Cypher and evolve the database product, as well as do work inside of OpenCypher to continue evolving Cypher so that, in the not too distant future, you can say that Cypher is GQL conformant. And at that point, you can call it GQL, you can call it Cypher. In the long term, probably we'll call it GQL, but it will be a easy way for users to get onto it.
So for folks who are already familiar with SQL, there's elements that they'll recognize when they look at Cypher. And so if they just kind of get their feet wet by like taking a look at Cypher as it is today, because there's plenty of examples, I guess you can find blog posts and things about Cypher, that will set them up well for kind of continuing on into GQL as GQL continues to move forward, is right?
Yeah, that's right. From essentially from the day that ISO voted in the effort, and we sort of went all in 2019 and said we're going to start evolving Cypher based on what we know of working in the GQL process to look more like GQL. And then incidentally, GQL ended up looking a lot like Cypher. So there's been some convergence already.
Right. Okay. Cool. I mean, this is so much fun. And so then this is the other aspect that I think is really interesting about this the way that languages started. And like you mentioned, Andreas Taylor, an engineer who, kind of got the start with Cypher, that this was is it fair to say like it was almost like an engineer who's scratching an itch, wasn't setting out to create an ISO standard back at the time? But then as you touched on this, it was like, okay, this was something that kind of worked for expressing like a way to query the database. But then having gotten this abstraction, like underneath the hood, you could do all the databasey things you needed to do. Now that you've got a good kind of language abstraction for talking about graphs, right?
Yeah, it's funny how innovation comes about. In fact, the name Cypher was chosen specifically because that engineer didn't consider himself an expert in naming, and didn't and chose the only name that could not possibly end up going live in a product called Neo4j, where of course the villain in the movie The Matrix, the anti-Neo, as it were, is Cypher. But there you have it. Kind of the name stuck, the language stuck. Ultimately, it was the users who chose the language. We had back in the day when I joined, and when you were there when I joined in 2012, we had Cypher, which was still very early. You had Gremlin, you had Blueprints, you had the native Java API, you had REST. You had at least probably like 5 different ways of accessing the graph. And as time progressed, and it was really, really clear that what users wanted was Cypher. And so by the time we went all in on Cypher as a Neo4j implementation, it's what users were using 99% of the time when they had the choice.
Right. And so something that started in that way and then progressed all the way now to being an international standards organization standard. I'm amazed at actually what it almost seems like the kind of beautiful timing of this, like as a language standard to come out that is now cross-vendor embraced at the time when GenAI obviously is on everybody's minds in the last year, and knowledge graphs are being part of that story. That knowledge graphs as well are like perfectly timed for like what's happening in GenAI and integrating GenAI applications with databases. And now we have this beautiful vendor neutral international standards language for actually integrating knowledge graphs with GenAI. Was that always part of the plan?
I wish I could have predicted GenAI. It's a pretty nice coincidence, actually, that just as knowledge graphs and digital twins and the world is becoming more connected, there are all these background trends already that have generally been a little bit more slow moving that play well into that make property graphs a really good fit and solution. But wow, just having GenAI show up, and my realization over the last year or so has been that you've got LLMs, you have and fine tuning, all the things you can do there. You have word embeddings, and then turning those into a vector, and then vector search over that. So i.e. vector index, vector database. But it's that precise kind of vector based on words and statistics around words, that all does all these amazing things, but it's very right-brained. Like it's mostly right. It's kind of intuitive. You don't really know why it's doing what it's doing. It's sometimes wrong. It's sometimes really wrong. No idea why. That's you can sort of tighten it up and load the dice a little bit, but that's all very right brain. And knowledge graphs complete the brain by giving you a left hemisphere, which is more declarative and exact and represents a domain's the specific part of the world that you're trying to represent, and your business's domain, and possibly declarative rules around it if you want to go there, but it's not even necessary. So I'd say that having that part of the standard locked down, having that part of GenAI, which is rightly a Wild West as we all figure out what it can do, and new technologies are popping up every day. But to at least have that part of the stack with graphs be clear when you're working with a property graph and you have a knowledge graph, you can you will be able to use GQL. I'm not aware of any GQL implementations yet, but Cypher, currently for users using databases like Neo4j that support Cypher, and there are probably a dozen others that you've got a really clear path to GQL. It's mostly GQL. When Stefan comes back, we can get in maybe a little bit more into the nitty gritty of what's in GQL that's not in Cypher, but also what's in Cypher that's not in GQL. There are a lot of things that couldn't make it into the V1 standard that are still useful in Cypher that might eventually make it into GQL.
Right. So, Stefan, I think this is, let me see if this is you who's just joined us back again. Are you there? Whoever's just joined will, if you manage to unmute, you can go ahead and speak up. So this aspect is really fascinating to me, like about what you're describing with knowledge graphs and like with GQL as a way of like talking about knowledge graphs generally, and this idea of pattern matching. In the world of GenAI and LLMs, like this is such a really great complement that even as like people like who are building what's called RAG applications, these retrieval augmented generation applications for GenAI, that for me, having gone through this journey, with you from like Neo4j as a data model, and then we built this language later on, some of what's happening on the data side in RAG applications sometimes feels like it's early days before we had a language to talk about what's happening on the data side in RAG. Really great kind of application level work happening in the orchestration layers, with Llama Index and, other orchestrations like that. But then when you're accessing the data, it's like, hey, I've got a vector, do a vector search on that. And like, that's the entire data model. Like there isn't really an expressiveness or a logical way to think about it more broadly. But a knowledge graph, it feels like it does. It feels like that gives you something to kind of really hook into in a much nicer way.
Yeah, I think the distinction here is it's tempting to want to think of the LLM as including everything and as being your data model. Of course, it's invisible, like it's a neural network. We kind of know what it looks like, but we don't know exactly what it looks like in each given case. But then, it doesn't, there are things that a database does that are useful and important and arguably necessary in many cases that an LLM doesn't. And as with any new technology, it takes a little while to pull apart what each one is good for and useful for. But I think for me it's the idea that the LLM stores a huge body of knowledge, generally comes from unstructured places, is trained at particular points in time, and can answer, can generate text that can be used as answers. But then the more precision you need, the more math, obviously, the more recency, the less latency, the more complex the question, and the more detailed the domain, the more specific the domain. All those things tend to not be as natural a fit. So this is where having a knowledge graph that is richer, in addition to vector word embeddings, which represent, like you said, it's one data type they can be ascribed to chunks, which have statistical meaning, and it's really great, but not as rich a model for sure.
Mm-hmm.
Stefan, it's so good to see you back.
Hello, am I audible now?
You are audible, you're clear. All right.
I have no freaking idea what happened there. This is the setup I use every day. And I've been remoting using this setup for 10 years for Neo4j or so. So it should work, but yeah, you never know. Okay, sorry,
that's all right. We're glad to have you back. Glad to that you figured out whatever's going on, and you've gotten a little bit of grace. You've spent the last 5 years of your life off with a team of people at random locations around the world, quietly in secret, maybe not totally in secret, but like building this language. So
yeah,
you're now you and your friends are all in the history books of having created a new language. You can have some audio problems. It's okay.
So there has the discussion gotten to.
We were at the moment we were talking about like sort of the intersection of like ISO GQL as this kind of broad language for expressing graphs, of course, and like particularly with knowledge graphs, and then how that relates to GenAI. But I want to go back a little bit, and we can come circle back around to GenAI if we'd like. But I'm really curious about like some of the earlier things you're talking about, and the evolution of the language and creating this standard, and something that Philip mentioned that I want to get your comments on about how, okay, this is a new language. And my question was, okay, why do we need a new language? Can't we express everything in SQL? And Philip was talking about like, the kind of the schema, the immersion schema, or the lazy schema, late schema, however you'd like to say it.
Flexible schema.
Right, yeah. I was curious about your comment about like, why do we need a new language? Why can't whatever we were expressing just be expressed in SQL?
Oh, well, there's a couple of ways to look at this, right? One is, of course, you have a new data model. SQL was deliberately designed for the relational data model, and that changes a bit language ergonomics and how you want to approach things syntactically, right? That's maybe one argument, right? Another thing, personally, I wouldn't necessarily see it as, as an opportunity, actually, because SQL is 35, 40 years old. It has served the database industry really well for what it's doing. But over the time and of those years, it, of course, has accrued a lot of craft and technologies that supports that are no longer up to date, right? One of the great things that GQL can do is pick from this great kind of fountain of SQL and pick out those things that are kind of in line with current technology, current trends, and established standards. And that's exactly what we have done, right? So it prevents an opportunity to take the best of SQL in a compatible way and reshuffle it in a way that points to the future of, graph and maybe now even GenAI, but is more streamlined, more compact, and, more organized for what's needed today.
Okay. So Philip, you're mentioning this a little bit like that. What was your phrase? Something about like not idly changing or varying from SQL, like using that as this, right? Oh, Philip, you might be muted now. Hold on.
You're muted, Philip, it seems.
We can only have two people
I'm
speaking at a
muted.
time.
No idle variation.
No idle variation. Yeah.
Yeah. I am super curious. What? How did that unfold in the day-to-day?
Well, we can make that concrete, right? That unfolded, for example, by only supporting Unicode character strings and not dealing with code points and character strings from the 80s, which we do not support in GQL, right? But we do support, of course, Unicode also with similar syntax for literal escaping and so forth, and all those details in a way that is compatible with SQL. So kind of taking that just as an example, right? Always going with, okay, what has SQL done in the past? What of those bits do we need really for moving forward? What people have come to expect from modern languages, and sticking with those, but sticking with those in a compatible way, right? There are similar areas. One would be numbers, right? Another would be datetime, where we've always tried to kind of strike this compromise that picks what has become de facto the expectation of current application development, but do it in a way that honors essentially the SQL or the database industry tradition, right?
Mm-hmm.
So no idle variation, but no idle copying as well. Don't bring something in from the main
just for the sake.
Right, exactly. And sometimes even going a little bit further. For example, having a dedicated suffix for specifying decimal numbers. That one we actually took from C# because that wasn't done before. So in GQL, you can be explicit that 1.5 is a decimal number by appending the letter M, right? So there are also tiny twiddles as a part of that. Of course, you're trying to not just take things over, but also make them a bit better where that seems appropriate, right? Of course, without breaking compatibility, right? So,
so what are the other languages, I guess, that inspired this? You mentioned some sort of graph languages, some inspiration from SQL, but now you mentioned C#. Were there other ideas that were borrowed from other places?
Well, I think in general, in the kind of lower level bits of language design, the stuff that's not as exciting as pattern matching, right, and graph schema, but which nevertheless somebody has to do. We've always taken the view to look at contemporary programming languages in general and what is established practice there, to try to get the database world a bit closer to kind of what modern application development would expect things to be like, right? And so these were just two examples, right? And the other big thing that, of course, we have done is linear statement composition. Most people know that here on the call, at least, that they know Cypher, that Cypher is written in a top-down style, right? And some people even say on the committee, if you ask them over beer, well, they think it would have been better if SQL would have been designed that way. But here we are 35 years later, right, where we have select, and then you have, your eyes have to kind of, when you learn reading and writing SQL, your eyes have to learn a particular dance of how to read that, right? Group by, order by, having, right, going in interesting circles to know how to read a SQL query. So, and I think we've really done better by adopting the linear style of Cypher, which allows really reading a query in the same way as you write things in programming languages from top to bottom. But of course, also for the sake of compatibility and in the general spirit of wanting to support as many vendors as possible, as many different implementations as possible, something that's very important to ISO. We also support select queries for people who care, right? But I think the intended style is top-down of GQL.
So select versus, I guess that's the alternative. It's like, oh, start what you want to return at the top versus Cypher's version of like you return at the bottom.
Yeah, you build up, right? You start with nothing and then you build up things. You're saying, okay, get me these nodes, get me those relationships, maybe keep only those that, I don't know, are born in a certain year and so forth, right? And you start from nothing building up your result, right? Instead of kind of saying, select style, I want those things, and here's like a complicated dance of what those things might be, which is kind of backwards that way.
Right, okay. And so do you have a favorite part of the language? Like, and maybe that's hard to, sort of pick one. Like, you were the editor, you were overall, like, your role was kind of to be the, I don't know, is it the referee? What's the role of an editor in this process?
Oh, that's interesting. I mean, at the most technical end, I'm a human patch applicator. Right? The way it works
the
is
Stefan diff engine. Is that what it is?
Yeah, that's kind of what it is, but it's a very intelligent diff engine, and it's not yet GenAI, I think. No. So what's happening in the process is, right, people write discussion papers. Or generally you write papers, like, in order to communicate ideas about what should be in the standard, what should not be in the standard as part of the process. So everything is very document driven, right? And then people write response papers, and that goes until at some point somebody writes an actual change proposal. Now, a change proposal is a paper that says, I want into GQL this feature. I want, I don't know, a new feature in pattern matching, like quantified path patterns. And that's how I envision it should be specified. And also those change proposals can go through multiple iterations, but sooner or later, the thing ends up in a meeting in ISO, and then it gets decided, right? And let's say it gets accepted by the group, right? And by the way, the group runs by so-called ISO consensus rules. So it's kind of, we really try to find consensus and leave nobody behind in general. And then it falls on the editors to kind of take those changes and put them in the document. And now there's a mechanical side to this, where you just copy them in as written in the actual document. But then there comes the hard part, right? Because next is you try to change the wording, you harmonize everything. Sometimes you reword whole paragraphs. You kind of try to make things in harmony with the rest of the document, with ISO rules. In a few cases, you fix bugs that the author has made, and then that needs to be communicated between the author and the group. So it's a fairly evolved kind of process from the point in time when actual consensus or rough consensus is reached in the decision process to when it actually goes into the standard, right?
Okay.
And kind of that last mile of the process is what the editor does, right?
Okay. And so then, and of course you've been involved with everything, but everything at some point you've actually had your hands on keyboard for any particular feature. If copy and pasting, or maybe like tweaking, there's probably very few words that you haven't seen in the standard. I'm sure everybody's read the whole standard who's on the committee, but you've had to like meticulously go through a lot of it.
Yeah.
And in that, like, so let me circle back around here a little bit then. Was there something that, or maybe I've got two questions, but I'll start with the first one again. Do you have a favorite part, like something that was newly added or some aspect of it that you thought, oh, actually, I really love this. This is a beautiful expression, or, like Phil, you mentioned earlier, like, somebody commenting on like how Cypher pattern matching was a beautiful way to express joins. Was there something like that, Stefan, that gave you kind of like a satisfaction, like, oh, it's a language feature. This is a very nice language feature.
So hard to pick, There's a lot of nice things in there, right? One thing I personally like is that we provide alternative syntax for what in Cypher is this. So you can break up this into individual things. So you can kind of let and just bind a variable, or filter and just perform a filter. So instead of having this umbrella thing that does very, very many things at once, a bit similar to select, we broke that up in GQL. So that is something I like, right? The top-down stuff, the top-down style I already mentioned earlier, right? And then, of course, and maybe that's something you want to transition into anyhow, is good to get into a bit, is that GQL is designed as a language platform. That is really like, it has a catalog that can address different kinds of database objects. It currently returns tabular results, but it could also return other tabular results. So we really kind of try to design a language that can carry us forward in the long term.
Right. So while it has, this is the 1.0 that was just released.
Yeah.
This is in some ways just the platform. This is the baseline from which the language will continue to grow for another few decades, perhaps.
Yeah.
Is that the intent?
Yeah.
Philip, if you had to, like, whisper into the ears of the editor and, like, plant a seed for, like, hey, in 10 years from now, I'd love to see a new feature. Do you have some nudging you'd like to do here?
Ooh, so one we've been talking about for years is views. So having some a lot of the work is in the implementation, right? But actually getting the language spec settled is a good thing. I will say, can I name a part of the standard that I like?
Oh yeah.
So I really appreciate that the standard came with standard error codes, actually. I think that's maybe a non-obvious thing when you're thinking about, usually we think about the syntax and what you send to the database, but then having, standards as far as what the database sends back. And Stefan, I'm wondering if you can talk a bit about those. And this has actually been a big effort inside of Neo4j, is getting ready for a big change to the error code system that is going to be GQL conformant.
Yeah, so that was also an interesting exercise in finding compromise between the world of SQL and kind of maybe what you find in programming languages, right? So if you go back into SQL, it has a so-called thing called a SQL state, which essentially assigns an error code and has like a two-level, has like a very coarse classification and then very fine-grained things like, you can have data exception as a class, and then, I don't know, number out of range as the kind of subclass, and then you have a code for that, right? And that's what gets raised, right? And that was the baseline, and we wanted to stay true to that baseline, so we came up with a thing called SQL status, which is essentially the same idea. But then, of course, we went a bit deeper and wanted to do things a bit differently. So we can return multiple GQL status codes, for example, in order to also allow vendors to ship things like notifications and other diagnostic information, right? We added the concept of an optional cause so that you have another angle of differentiation. So, and that is done, of course, in general, when you catch errors, you want to write as little code and as stable code as possible. So you want to have stable errors, but at the same time, sometimes you just want to channel more information to the users, more diagnostic information, right? So with this cause mechanism, right, it's possible to test for the high-level error code, like transaction could not commit, and then maybe you get a cause that gives you more detail, right? Whatever went wrong. Maybe some cluster node went out of storage space, or who knows, right? So we kind of try to take this existing system, again, following the theme, and then expand it along various dimensions to make the whole model a bit more flexible and modern, right?
I love that call out, and thanks for the explanation, Stefan. Like, as a developer, from my perspective, you don't appreciate error codes until you need them, and then you're so grateful for thoughtful error codes to actually help explain things. Like, it's great when everything's good, but as soon as things go wrong, when we've all run into these situations where, like, you have no idea, no hope of figuring out what went wrong because the error codes are not there, or they're not very helpful, they're not very explanatory. So having that kind of baked in from the beginning is super nice. That's good ergonomics for developers. And Philip, you mentioned having views as well. Is that something that's in the works, Stefan? Like, I guess that didn't land for 1.0. Is that?
Yeah, sadly. So the other thing that one does as editor is writing the initial draft, because you need a document to get started with, and the very early versions of the draft actually had views, but they simply got cut out, and I think for good reason, because right now there are no vendors providing them. Right, we have no language cipher-based or something close to it that really provides, at least in a commercially viable product, provides views at this point of time. There's some prototyping work on that area. Some people might remember Cypher for Apache Spark on the call, and also other academic projects like what happened around GCore. Right, it has been tried, but I think it will just be more time until vendors are ready to really ship that with the quality you need for a highly scalable commercial database product. But of course, it would be very desirable to have them, because they enable so many things. They provide a form of encapsulation, right? They can make security more flexible, right? They make the language composable, right? Which means that you can write queries that return graphs, actually, maybe for visualization in the client, for exporting, for importing, right? So I think a lot of good things can come from views. It was just more important to get the baseline done, I think, for version 1, for all of us to have an actual international standard for querying with pattern matching, right? And we have that now. But certainly views are on the wish list of a lot of people for potential V2.
Yeah, and to add, the scope of V1 is significantly larger than the original scope of the first SQL standard, SQL 86, which landed in ISO in 87. Keith, I'm looking at the chat, and there's some good questions there, including some being answered by Keith Hare. You'd asked about who the arbitrator was. Actually, Keith is the chair of this, has been chair of the SQL committee for 20 years or so, and that includes the GQL committee, because it's more or less the same committee, though Stefan and Keith will correct me as to all the, all the perhaps the finer details. But this standard is, according to Keith, who was there back in the day, more comparable to SQL 92, which is and turns out the page count is identical or nearly identical to the page count for the GQL spec. The GQL spec has something like 400 technical papers, including, in addition to the 600-page doc itself. So it's quite a lot, in other words, for vendors. Yeah, there you go. Yeah, and that, by the way, is written in a language that's not readily understandable by your, it's built for database language implementers, not for end users. So we can maybe come back to that one, but I expect that it will be, there's years worth of work to conform with things in the existing spec, and then there's also options in the spec for vendor extensions. So some of the things that Cypher does that are not yet in the spec are supported as vendor extensions.
So let's dig into that a little bit. So we talked about the differences between SQL and GQL, and with Cypher being one of the reference points for GQL, what is the distance, I guess, from Cypher to GQL? Is it 2 years different, or is it like, I guess that's implementation time, but like,
I think we should both give answers, because we have slightly different angles on this. So I'd say and let me tie back to a question that someone asked earlier in the chat as well, around, what are the things that are going to drive vendors to ultimately support this thing? And then the related question is, what are the things that are going to drive end users? And those things are obviously related. They're a virtuous cycle. And are there users in particular industries that might push for it more, and so on? And I guess if you look at the obvious way you would think to actually implement GQL, it would be you have all existing languages, and they're on this track, and then you have GQL, which is a different track, and you need to sort of jump sideways to a different train track at some point. And that would be, it'd be worth the effort, right, to do that. But you can also see how, all right, what does that mean for my skills and certifications and code and applications that are in production and so on?
Yeah.
That could be a disruptive thing. So what if we could merge the train tracks in some way that by staying on, the particular train that you're on, and I'll speak for the Cypher one because that's essentially the train that we and our users have been on, is there a way that we can merge it in? And so I mentioned earlier that there's some pre-work that had been done to get Neo4j, the product, and Cypher, the language, more ready for GQL at the same time as Cypher was an input, major input to GQL, along with some other things. Stefan slid this in earlier, something called GCore, which was a ground up academic project that we and many others participated in to create a graph query language from scratch with no previous, no assumptions. Turns out that ended up looking a lot like Cypher and like GQL. So that's good validation, right? You can start from scratch and end up roughly at the same station. So back to your question, what are the things that are similar? How far off are we? The core pattern matching is the same. So that's a huge deal. That's the heart of the language. And then a lot of the keywords are the same. That's the style of construction, as Stefan mentioned, is the same. Most of the data types are the same. Stefan, you can maybe elaborate more on that side, but the data types are roughly the same. So, we're definitely within the same zone. And so we're enough in the same zone that you can actually have a convergent path to the GQL track. And then what are some of the things that are different? Well, you have this idea of mandatory conformance features in the standard and optional things in the standard. And then you have this idea of vendor extensions. So if you sort of break that all down and map it into Cypher, you could say that the core and the essence of the language is there. There are things that are mandatory features that are perhaps a little bit more, checkboxes that need to be filled, but that requires some technical work to do. But that at the end of the day, as an end user, are maybe not that impactful. But if you're a database vendor, it takes some time to build. So that's sort of where we are. Is there's some amount of that work that needs to happen. Mm-hmm. But really the takeaway is, if you stick with Cypher, and particularly as Cypher will continue to evolve to ultimately land you into a place of GQL conformance with the Neo4j product. And then we're going to be contributing things back to OpenCypher, and there are some other efforts that are starting up that are industry collaborations around let's take the GQL I see a bunch of questions around in the chat about hey, this document's expensive, is there some other way I can get it? And for better or worse, the ISO ISO policy, we can't change that, so they charge for the document. It's ultimately an ISO product, but at the end of the day, it's not like it's interesting for sure, but not as useful to users. It won't help you write queries. It'll help you build a database that supports GQL. Yeah,
it's probably similar to the ISO SQL standard, which probably very few of us have read. The standard, right? Like I've never read it, but I can write SQL.
That's right. Yeah. So at the end of the day, like, it's on us, the vendor community, to create user-facing docs for how to use the language, for implementing features, for if you follow the Neo4j blog, we've tried to do our best to get some blog materials out there. And towards the bottom of the chat, I see someone dropped in a link to a document that actually Keith had a pretty big hand in writing. That's maybe we can repost that in the chat. It showed up at 9:09 with more information.
So in fact, for any of the links that come up, if people have things to share, Keith, I know that you're still with us here. If you got links you want to share, if you add them to the chat, I'll collect all those, make sure to add them to the show notes when we post the video of recording later. So we'll capture all that stuff. And so for Stefan, like, from your point of view, like what's current distance from Cypher? Like, does that seem like reasonable that people can invest time in Cypher today? That's not time wasted because this will continue to evolve as Philip has described, and it's not.
Yeah, I definitely agree with what Philip has been saying here in terms of kind of the picture from a knowledge and from a learning perspective, but maybe a little bit from a slightly different angle. I already mentioned earlier, right? We talked about mandatory features and optional conformance features, right? But the philosophy behind all that is that really the committee wants to enable adoption as much as possible, and if you want to do that as a committee, you want to make it as easy as possible for vendors to get to that first point in time where they can say, we provide GQL now for our system, right? And for example, one thing that we do support are read-only implementations. So you can be a GQL conformant implementation by just exposing match return, right? And there you have your Cypher skills, right? Maybe we'll see endpoints like that where people expose graph data from some, proprietary system that already has that, right? Through those means and provide GQL that way, right? And that's a perfectly valid way to go, right? And does not require getting into all the other parts of the specification, right? And so then on the deviation from Cypher part, right, there are tiny things, and mostly they come out of the interaction with SQL. And in a few places, we have actually decided to side with SQL here in order to kind of stick to established legacy of the database industry, but in doing so to also enable tool vendors, for example, to also be able to target GQL, right? One prominent example, aggregation functions. Certain aggregation functions have slightly different behavior in Cypher versus in GQL, and I think we'll find that out at the right point in time how we're going to deal with that in Neo4j, the product. So that would be one of those tinier annoyances, right? Everywhere else where GQL is different from Cypher, it rather goes beyond it. Like I already mentioned earlier, Cypher has this, GQL does not have this because this is a keyword in SQL with different meaning, and we didn't want to overload that. So instead we have let and filter, for example. So we've kind of, in a few places, have done new additional functionality using new additional syntax, right? But as already stated, the core of the language is the same. Match return is kind of where the action is. Use of pattern matching. Also, I don't know if you mentioned that earlier because of my audio troubles, right? Pattern matching is not only used for describing data to get out of the graph. Pattern matching is really a theme that is used throughout the language. It's also used to describe updates, right? GQL has a full update language for data modifications, right? It is used for schema, for graph, what we call graph types. So when you actually want to specify schema, you specify that using pattern-based notation. So it runs much deeper to the core of the language to really take advantage of this visual appeal, that was pioneered for Cypher, right? So in that sense, same structures, often same syntax, sometimes additional syntax, in a few rare cases, slightly different semantics. That is the price you pay for having an international standard. But I think everybody today investing into Cypher has the right skill set to adopt to that.
But I hadn't realized that aspect that you were just mentioning now. Like I've been trying to follow along with the standards as it's evolved, but it is a lot going on. But I love that particular idea that this key insight of like, okay, patterns are a nice way to express things within data, and that concept echoes throughout different aspects of the language, I think is super useful, because once you've got that in your head, like, okay, just think in terms of patterns. And if that mental model can be applied wherever you are interacting with the language, that's really nice. That's very helpful for people. Like, here's one of the early things you need to learn: think in patterns. And then here's how you can apply it. The pattern applies in schema. It applies in the migrations, as you're saying, or is that right? In migrations, effectively, or like you were saying, graph updates.
Yeah.
Right. Okay. That's really nice. I then have to ask, and I see Keith. By the way, if you're not in the chat, shout out to Keith here, like for so many things, including giving great answers in the chat here. He's been marvelous. I have to ask, because as we're closing around to the hour here, so many people have been involved with this, and we can't go through a full list. I want to call out Keith because he's here with us today, and like you've been amazing through this whole process. who else should we give some thanks to that's been involved?
Yeah, that's an interesting territory because, of course, there's a lot of people, as you said, who have really helped make this happen. I think personally, I would always give a special shout out, of course, to the team at Neo4j who has been working on this. My colleagues Hannes Vogt, Finn Bagut, Nathalie Chabel, right, who've been on it all those times. We should definitely give a shout out to Andreas Taylor, the initial creator of Cypher, right, without whom we wouldn't be. Philip mentioned him already earlier, right? Definitely also to Alistair Green and folks at the Linked Data Benchmark Council who have been kind of shepherding and guarding GQL in many different ways through academic work, through discussions in an open industry forum, which I think has been very instrumental in helping make all of this happen, right? And last not least, to all the people on the committee who have been shepherding SQL for 30, 35 years, because you don't get to create, a standard like that without getting a lot of helping hands that basically show you the ropes how to do it, whether that's on the editing side, on the paper writing side, right? So
yeah,
thanks to all those people. Yeah.
So we'll include some links for all that. Then you mentioned the LDBC, you mentioned, of course, the council itself. We'll add some of those links to the show notes. Philip, anybody else you want to give a shout out to or recognition you'd like to provide?
Yeah, it's so hard to pull to pull names. As Stefan named a lot of good ones, and I'll just say more generally that this is an area where everybody sets their differences aside, in their commercial differences aside, keeps their intellectual differences, and then goes all in. But then also comes out with with agreement. So it's been a pretty amazing process of just seeing a lot of people who, in other contexts are competing or have different kinds of products or and so on, and just setting those differences aside for the benefit of doing what ultimately is right for the user. This is all whom we're trying to serve at the end of the day.
I love that aspect. This is something that is coming through whenever the topic has come up in the discussions around GQL. There is this feeling of serving the greater good, I suppose, in a way, like to be almost melodramatic about it, but it's like, okay, exactly as you say, Phil, like, okay, people come in from their whatever backgrounds they have, whatever commercial interests they have. But when you get down to the actual discussions, it is intellectual discussions. It is, let's have intellectually rigorous, honest discussions, like talk through language design, building a new thing together that's everyone's going to benefit from, right? And that it's been pretty amazing as an effort. So I personally would like to thank the two of you. Certainly everybody else who's been involved that you've mentioned, Stefan, but like this has been amazing to watch from the sidelines. Congratulations, I should say, I guess as well, both to you and again, everybody on the ISO committee. It's an amazing feat. This is since, what was it, 1987, 1986, since SQL debuted, that we now have a peer language available from ISO. That's pretty marvelous. So a milestone.
Thanks. Yeah. And congrats to the committee and to our, and I'm so happy for our users at the end of the day that you're going to get effectively an on-ramp that, and end up with something that is highly compatible with what you've learned, what you've got on both the Cypher and the SQL fronts.
Yeah. So fantastic. We've got to close that now, but for anybody who's still dialing in or who's been going to see this later, please add comments to this thread. We're going to pay attention on all the channels where this is available. If you've got more questions that weren't brought up during here, please ask the questions. Let's talk about it. Let's find out what you want to know, and we'll provide the answers we can, or we'll bring in people who can provide the answers. So good to have everybody here today. Philip, Stefan, thank you both so much. Glad this really worked out. This has been amazing.
Thanks for having us. Thanks, Andreas.
Bye,
All right, everybody. Bye.
Bye.